So shell method, after this long video of describing this, basically what we have been doing is we have been doing the washer itself, right? So we've been doing pi r squared, the area of a circle, which is why our functions have been squared. We have a pi on the outside, and then we're doing r squared, right? And that is a circle, area of a circle. And we've added up a lot of circles. Or we've added up the difference of two circles if there was a hole in the middle of it, okay? And so we were doing area over and over and over and over to get what we needed. Now we're actually doing volume. And so this is why you're going to see the 2 pi r, which is your circumference, times your height, which is the function, times your depth, which is your dx, however x is changing, okay? And so you're no longer squaring your functions when you get to the final thing here. You have the 2 pi, that stems from your 2 pi r circumference formula. Your r is going to be how far away from the revolution that you are. So if you're revolving around an axis, it's really nice. If you're revolving around your axis, y-axis, your x is going to be your r, because how far away from the y-axis? Well, that's x, right? If you're revolving around the x-axis and you're doing a y evaluation, well, y is going to be the distance away from the x-axis. That's what that means with y. When it changes is if you're revolving around something that's not the axis, and we're going to do a couple of those, I think, tomorrow. I don't think we do that one today. But and so when you revolve around something that's not the axis, then your r is just the distance from the axis. So let's say we're revolving around 2. Well, 2 minus x is going to be our distance away from the axis. And so a little bit of shifting comes into play, but not as much as in the washer and the shell method. But what I do want you to pay attention to is when I am revolving around a horizontal axis of revolution, that is my x-axis, or y equals 0, all right? Y equals 0. It is in terms of y. So if I'm revolving around my x-axis, it's going to be x equals something. This is opposite of the disk method, okay? The disk method said if I'm revolving around the x-axis, then it needs to be in terms of y. Y equals 0, so all of my functions equal 0, right? Vertical for shell method. If I'm revolving around vertical, then it's in terms of x, where this is opposite of the disk method, okay? So with your disk method, if you were revolving around the axis, it needed to be in terms of that axis, all right? This is the opposite thing. And so we're going to do a couple of examples, and then we're going to look at the comparison between the two. This says, find the volume of the solid of revolution formed by revolving the region bounded by y equals x minus x cubed and the x-axis. And then 0 is less than or equal to x, which is less than or equal to 1. And we're revolving it around the y-axis. Okay, so we are bounded by this function and the x-axis, right? They've told us that we're going from 0 to 1, and we want to revolve around the y-axis, all right? So the y-axis, if I were to write that as a function, that would be x equals 0, yes? So this axis right here is always x equals 0. Before, if I had it as x equals 0, I would have needed to rewrite that function, right? If I was revolving around x equals 0, then my function should be x equals something. That's how the disk method works. This is not the case. In this case, it is in the format that we need it in, y equals x minus x cubed. And so we just have to go from 0 to 1 like they told us. We're going to use our 2 pi, all right? Now, we are revolving around the axis itself. So if I need to know how far away my function is from the y-axis, how far away is x from the x-axis? It's x, right? And so my r here is 2 pi r. My r is just x. My height is my function, x minus x cubed dx. And that's what I am going to take the antiderivative of. Before you take the antiderivative of, simplify this. We get x squared minus x to the 4th. Once you simplify it, then take your antiderivative. The antiderivative of x squared is 1/3 x cubed. Antiderivative of x to the 4th is 1/5 x to the 5th. And we're doing that from 0 to 1. And then you just plug in a 1. So when we plug in a 1 here, we get 1/3 minus 1/5. Common denominator is 15. So these become 15. This is 5. This is 3. So we get 2 pi times 2 over 15, which gives me 4 pi over 15 as my answer. Questions on that? So, find the volume of the solid of revolution formed by revolving the region bounded by the graph x equals e to the negative y squared. It's bounded also by the y-axis. Your y's go from 0 to 1, and they want us to revolve around the x-axis, all right? So the x-axis is y equals 0. They want us to revolve around y equals 0, right? Well, if I had to do the disk method, what would I have to do to this function right here?
Change it.
In terms of y, which would mean I'd have to do natural log of both sides. I'd have to expand it. Like, there's a lot that goes on that would have to happen here for me to change this, right? And so in this case, I am going to leave it alone. So I'm going to go use my shell method here, and I'm going to say, well, I'm going to go from 0 to 1. We're now on the y. My r then is the distance from the x-axis. Well, my distance from the x-axis is going to be my y value. So I'm going to say my r is my y value. My height is going to be my function, e to the negative y squared. And of course, my depth is my dy. Now, if I were to use u substitution here, my u would be my negative y squared. My du would be negative 2y. I have a y. I'm going to end up with a negative 2y, right? So I need to multiply both sides by negative 1/2, right? Does that make sense? So I have negative 1/2. That's going to help me get rid of this part here. Times the 2 pi. 0 to 1, right, of y e to the negative y squared dy. Which means this is included in it. I don't have to worry about that at all. You can just worry about taking the antiderivative then of this part right here. If I said e to the u, right? So what's the antiderivative of e to anything? What's the antiderivative of e to a function? It's just e to u. And so then I can replace that u. So you don't have to do u substitution. You could just leave it as long as you know to put that 1/2 out there. These simplify, negative 1/2 and 2 simplify to just negative 1, right? So negative 1 pi. And we're going from 0 to 1. I plug in a 1. I get e to the negative 1. And that's minus e to the 0. In this case, you have to plug in e to the 0 because it's actually a number. What is e to the 0? It's just 1. So you get negative pi, and I'm going to rewrite this as 1 over e minus 1. If you distribute that, it's fine, or you can just plug it into your calculators. They distributed it, and they distributed this negative through, so they ended up with 1 pi minus pi over e. But you don't have to even worry about that. You can plug it in right here and get 1.986. So pay attention to your u substitution here. You get a negative 2y. We just have a y. That's why we have to pull this negative 1/2 out when we do our u substitution.
So what happened to the y in the blue?
So I did u substitution here. I made my u my negative y squared. My du is negative 2y. I just have a 1y. So I did negative 1/2 to get rid of that negative 2. 2 pi e to the u. So I just replaced all of this with e to the u, du. This actually should be du. Antiderivative of this is just that. And I just replaced this back when I took my antiderivative. You don't have to write all of this out. If you recognize here that you're going to have a negative 1/2 in your final, you can go straight from here to here. But, you know, I was just writing it out to show your u substitution. So this compares the disk method to the shell method. And by disk, I mean disk or washer. Washer is just 2 disks subtracted, okay? So you'll notice that when you have a vertical axis of revolution here, that for the disk method, everything has to be in terms of y. So when I have a y-axis revolution, my functions need to be x equals something, because it's x equals 0 is my y-axis. When I have a horizontal revolution with the disk method, it's y equals 0, so all of my functions need to be y, and it's your terms of x, in terms of x, meaning dx up here. Okay. Shell is opposite. When I have a vertical, I am in terms of x, so it's y equals something. When I have a horizontal, it is x equals something. All right, so you need to think about what you're revolving around and which method requires what, all right? When you have a vertical axis, all of you're in terms of y here, dy, horizontal, dx. This is flipped. Vertical is x, horizontal is y. This is where it starts coming into play, which method is easier, okay? Because you're going to be handed something, and if you only learn one method, there's going to be a time when they hand you something and you cannot rewrite it in order to rotate it. And so you need to memorize the basics of the disk. Just realize the washer is just 2 disks subtracted. Memorize the basics of the shell. So you have either pi times your r squared, pi r squared, or you have 2 pi r times your height. All right? And so if you think of it in those terms, then what they're wanting you to revolve around will decide which one of those you're going to choose to use. Okay?
So pi r squared.
I'm going to set up the 2 pi r. 2 pi r is the distance away from what I'm revolving around. I'm revolving around the y-axis. My x value, whatever x value I am on in between here is is my r. So x is my r. My height is my function. So this tells me the height of what I'm revolving around, and dx is the depth. We're going from 0 to 1. So shell method is definitely easier. I would not want to set up 2 disks here. It would be a pain. And so I'm going to distribute. I have x cubed plus x here. I have 2 pi, and now I'm going to take my antiderivative. I have 1/4 x to the 4th plus 1/2 x squared from 0 to 1. Plug it in, you get 1/4 plus 1/2. Common denominator, that's obviously 2/4. So we get 3/4 times 2, which is going to reduce to 3 pi over 2. Now, if you look above at the top there where they did it by disk, they got the same exact problem. You'll notice the calculation was a much more difficult calculation. They had to do shifting. There was a lot more that went into that to do that disk method. For this one, I'm going to do 2 pi r again. I am still, the distance is still x because I'm still revolving around the y-axis. It actually told you that in your instructions. But my height is going to be the difference between the two functions because I cut the function off. It's not just the height of the function because I'm not bounded by the axis below. I'm actually bounded by the other function. So it's the difference between the two. So you do have to figure out which function's on top and which function's on bottom. You also had to figure out your boundaries by setting them equal to each other. So I set them equal to each other. Then I figured out between the 0 and the 2, which is the upper and lower of my caps, which is how this works out. The 4x minus x squared is higher than the x squared. So this is my 2 pi r and this is my h. And then I just simplified all of this. I combined like terms, distributed my x. That's where I got my 4x minus 2x cubed. Take the antiderivative of this, 4/3 x cubed minus 1/2 x to the 4th. That's antiderivative. Plug in a 2. When you simplify, you get 16 pi over 3.